Hello and welcome to chapter 21 on body fluids. Today we are going to look at why water is important, how water is regulated, where water is found in the body, a little bit about balance. We'll get more into how water is balanced when we get into the kidney unit. And then we're going to look at the electrolytes. Electrolytes are actually very important. They're not just something you find on a sports drink bottle. They are important to be in balance, and they actually control the movement of water throughout the body. So we'll look at them. We'll get briefly into the kidneys and the hormones, but we'll talk more about that in Unit 21 when we actually talk about the kidneys. We'll also look at how acid-base balance is really important. We'll talk briefly about this, but then we'll get more into it when we talk about the kidneys. And then just briefly touch on water disorders. And that's because of, quite often you hear about water on the heart or fluid on the lungs. A lot of it has to do with the too much sodium and not moving the salts properly. Then briefly talk about fluid therapy, because intravenous is very important and an easy way to move water just by changing the salt concentration or the sugar concentration. Okay, so when we look at it, first off, why is water important? Water is important because the body must keep a certain amount of water in it. So you have a thirst mechanism to maintain this volume. You have kidneys that regulate it. You have hormones that regulate it. Water is important because of buffers. When you breathe in and out, the buffers, carbon dioxide goes in the blood, makes that bicarbonate or hydrogen carbonate ion that we talk about. And then we'll talk also about kidneys and pH. Please notice with pH, it is a small p and a capital H. The small p actually means something. It means the negative inverse log of. And the H is hydronium concentration for you chemists out there. Now, when you look at where fluid is, there are two main compartments of it. The fluid is intercellular fluid, and 40% of your body is intercellular fluid. This is fluid inside the cell, inside cell, intercellular fluid. Then you have extracellular fluid. Your extracellular fluid is outside the cell, but it's in other locations. So there's interstitial. So think of it as intertisual. So inter means between. So this is the fluid between the cells, and this is very important because this is the fluid that washes the cells, as we talked about back in the circulatory system. Because of blood pressure, the fluid is pushed into this tissue, the area between the cells, and then osmotic pressure in the blood vessels pulls it back. If you upset that balance, it will change the amount of fluid between the cells. You want some, but you don't want too much, or you get swelling. Then water is also found in your intestine, in your blood plasma, very important because those are your blood vessels, and your lymph. It is also, some is in your skin. It is in your lungs, which is important because you must have a moist membrane in order for gas exchange to take place. And then your kidneys help regulate this amount. Very important, and we'll talk about kidneys in the next chapter. Now, when it comes to balancing your water, basically you have water gained by food and beverage, but notice a large amount of it is drinking. You should be drinking, this is 1.6 milliliters, 1.6 liters, sorry. This is why they say drink a liter of water a day. Some is in your food and metabolism. Remember how we talked about oxygen and glucose produces carbon dioxide and water? That is cell respiration. That water produced is a small amount, not significant in the terms of most significant water comes from drinking, and you should be drinking water, not juices or sugar or coffee, she says as she takes a drink of her coffee. I know, the osmotic pressure, the osmolarity of coffee is all wrong, but it's so yummy. Okay, then when you're losing water, you should be peeing about a liter of water a day. And when you're in the hospital, they love to regulate and measure that. And when you grow up and become a real nurse, you will be measuring how much pee in a bag, measuring it in that little gizmo that sits in the toilet. You also have some in your feces. If that's normal feces, notice if you have diarrhea, a lot of water will come out quick, and that's because it's moving through the digestive system so quickly. You breathe some out with your lungs. If you notice when you go like this, if you ever hold that up, you'll notice this is moist. That's because when you breathe or talk, you are putting some moist water out. Some comes out of your skin, not a lot, because your skin is if it's healthy, it's dry and waxy, and you should keep it nice and lubricated, but some comes out of your skin. This is why if you are sick, your skin will react, or if I eat too much garbage, my skin, it shows up on my face. You get that volcano zit that is going, hey, you fed me garbage. Okay. When you look at the electrolytes in the water, now electrolytes is just a common word for anything that conducts electricity. The electrolytes in their body are very important. And notice sodium, potassium. This is sodium and potassium and calcium are the main positive cations. Notice the word cation has a T in it, just like positive has a T in it. Anions, and notice it's anions in the pronunciation. Anions, negative, and they both have N's in them. So negative anions, positive cations. Now in your textbook, it does a beautiful job of breaking this down, which is more than what this PowerPoint does. Notice sodium is very important for osmotic balance. That's because your body will pump sodium and water will follow. Too much sodium, too much water. That's why high blood pressure, you get rid of sodium. Water on the lungs, move sodium. Potassium is also important for nerve function. This is the major ion in the intercellular fluid. It's involved in enzymes. Calcium, very important for bones, muscles, as we talked about, nerve impulse, and blood clotting, very important. As an older women, the decrease in calcium will, if you're not eating enough, it will take it out of your bones, making osteoporosis. Magnesium, again, notice if you read your multivitamin, there's magnesium. Now, magnesium is linked to action of some enzymes. There's talk that magnesium absorption is related to calcium absorption, which is related to vitamin D. Very interesting stuff there. Now, anions, the negative charged ions. Bicarbonate, which is also called hydrogen carbonate. This is an important buffer in the body fluids, and we'll talk more about that when we talked about the kidneys. But if you remember when we talked about respiration, as you breathe out, as your blood carries carbon dioxide, it's carried as that bicarbonate ion. And then if your blood is too acidic, you will just increase your respiration rate to get rid of that carbon dioxide. And that bicarbonate ion. Very important as a quick change, and then your kidneys will compensate in the long run. Chloride is important for hydrochloric acid in the stomach, which we talked about in the digestive system. Hydrochloric acid is the acid that activates pepsinogen to pepsin for protein breakdown. Also helps regulate fluid balance. Again, if sodium is pumped, chloride follows and water follows. Then you have your phosphate, essential for carbohydrate metabolism, bone formation, and again, acid-base balance. And we talked about phosphates in ATP. The P in ATP is phosphate. Phosphates are also used as that sugar phosphate backbone in DNA and RNA. Now notice, DNA and RNA are capitalized. Some of you are not capitalizing these words. I don't care if you're being lazy. It is an acronym. They must be capitalized. Communicate effectively, please. Okay, so those are your major electrolytes. Very important in regulating your body fluids. And we'll talk more about that again when you go back to the kidney. You need to know their functions, and you need to know the major one where they're found. Now, when we talk about acid and base balance, acid and base balance is very important. Your water balance must be, your pH is regulated. It's regulated, pH scale, little chemistry here, is based on a hydronium concentration or hydrogen concentration. Now your hydrogen ion is H+. If you have a high hydrogen ion, you have a lower pH. High hydrogen, acid, lower pH. So body fluids are normally slightly basic. If you remember, pH 7 is neutral, so you're slightly basic, and it is very important that your blood and your body fluids stay within a certain range. That's because if you change the pH, you will change your protein configuration, which means your enzymes won't work. And it says 0.3 point, it is fatal. That's because you have changed your proteins and your proteins don't work. Sort of like when milk gets old, the bacteria produces acid, which causes it to form that nasty clump. Now, there are abnormal conditions. Acidosis, you may have heard of ketoacidosis. That was a problem with low fat, low carbohydrate diets. Also a problem with, or a concern in diabetes. You can tell by the breath, it's got a ketoacidosis. It kind of smells like acetone. You also have an alkalosis. That's when you get more basic, too high. Now, the respiratory system and will produce this carbon dioxide. So if you're not breathing properly, your carbon dioxide will build up. Okay. We'll talk more about metabolic changes and when we get into the kidney. Now, in terms of disorders, basically you've got edema, which is swelling, water in the wrong place. Intoxication means you've taken on too much water and you've diluted your blood. And then dehydration means not enough and you've concentrated your solutions. There are ways of compensating with this. When it comes to fluid therapy, this is intravenous therapy, very important, and often one of the things you need to do is, and I love a nurse who can give you a nice intravenous line quickly, because intravenous is very important. And it's outlined nicely in the textbook. This PowerPoint doesn't do it. And I want you to look at it and think of it in terms of the osmolarity, or the concentration of ions. So when we look at it again, just a second, I need to find that page. There we go. The first one administered is normal saline. That's because it has a 0.9 salt concentration equal to what is in the plasma. It's isotonic. You just get fluids in there. You also have a line available in case you need to administer any sort of drugs. Very important. Then if you are needing nutrition, you have your dextrose, and you have 5% dextrose, and sometimes you go up to 10% dextrose. 5% dextrose is hypertonic, but the blood will take up that, the body will take up that sugar, and then it will become hypotonic after the sugar is used. You'll talk a little bit more of that. Then there's something called lactated ringers. This contains sodium, potassium, calcium. Ringers is a nice isotonic solution, but the pH is, it acts as if you have pH problems, your bicarbonate will act as a buffer and will help control it. This is used in terms of burns. And then you have your 25% albumin, serum albumin. Albumin is a protein, therefore it's 5 times normal. This is a hypertonic solution which will draw fluid from the interstitial spaces into circulation, and that will take fluid out of the body into the blood, and then it can be urinated out usually. Very important you get an idea of this, and also think of what's happening in terms of electrolyte movement and hypertonicity. Okay, that's pretty much it for this unit. Please make sure you pay attention to your word anatomy, because knowing your word anatomy will help. Edema is swelling, iso, and that is the end of chapter 21.